In this lesson, we'll be talking about matching. Matching is the most basic form of search, where we look for a substring within a larger body of text. As you can see, we have a search form that lets us enter a term, like the matrix. And as we submit the form, you will see there is a query parameter here that we sent to our server. And right now, it doesn't work because we haven't implemented it. We can start by taking a look at the controller code. Here we have an index action that first imports all the titles, and then it performs a search only if there is a search parameter present. If we open the title model, we can see that the import simply loads all the records from a CSV file. We can also see a search method here that's calling a search in memory class, instantiates it, and calls search on it. Opening the in-memory search class, we can see the search method that we call immediately calls a new method called match and passes the same arguments to it. This is the match method that we will be implementing in this lesson. We will do this in a test-driven development style, starting by writing a simple test and then writing an implementation for it. We already have an empty spec file, so we can begin by writing our first test. We can start by writing a spec for the match method. We set the subject to be the result of calling the match method on a new instance of the search in memory class, giving it a collection that is empty and a query that is also empty, and the new instance of our in-memory class. Next, we can write our test to see that when given an empty collection, we get back no results because the collection is empty. Now it is time to run our test. The test passed just as we expected. Next, let's give our collection a single record with a field called title. Since there is only one item in the collection and we know that there is a match, we expect that one item to be returned to us. Once again, let's run our test. As we expect, this also passes because we're just returning all the records. Let's write two more tests. One case where we find a match for a string we search for, and one that we know there is no match for a string. Once again, let's run the test. Perfect, just as we expected. The test where we searched for the Titanic found a match even though we expected to find no match. And that's because we haven't implemented the actual matching behavior. Remember, we're just returning the same collection that was given to us to begin with. Going back to our in-memory search implementation, we can use the select method to loop over all the records and pick up the first record where the first value matches the query string that we have. We don't need to worry about other values. We'll do it shortly. Great, now it's time to run the test. And a little bit unexpectedly, one of the tests failed. And if we look at the test, we can see that we expected to find a single item, but we didn't find any. And that's the case where we just pass it an empty query string. So we can fix it easily just by checking if the query string is empty. We can just return the entire collection. And now all of our tests pass. Now let's test what happens with multiple values. Going back to our spec, we will surround the existing spec that we have to better describe it with a single field. And then we will use that and copy it over to create our new test. We will modify our existing code by adding a cast field for Keanu Reeves, and then we'll put a query for Keanu Reeves. And we'll also modify it to something that doesn't match, like Bruce Willis. Running our tests again, we see that one of the tests fails as we expect because we haven't implemented the search on multiple fields. So let's do that now. We can do that by modifying our values to look for any value instead of just the first value. Running the test one more time, we can see they all pass, so that's great. Next, let's test what happens with multiple records. Going back to our tests, we can simply go up here and copy all of the work that we did with a single record, modifying the test description. To keep things simple, we can remove the section where we distinguish between multiple fields and a single field. This case is redundant and it is already covered by other tests. Now let's go ahead and set up 2 different records with 2 different films and the different cast members in there. Let's also just remove that outside context we don't need anymore. Our first test here will search for an empty query string, which should return all the records back to us. So we'll return record 1 and record 2. Our second test, searching for Keanu Reeves, should only find record 1, and our no match test will stay the same. Running these tests again, we can see they all pass. Finally, we can add one last test to test a partial match. Let's do that by copying this section up here and then modifying it to just search part of that string. Let's run the test to verify that we have a failure. Just as we expected, we have a failure because we haven't implemented partial matching yet. Going back to our implementation code, we can simply modify our loop to match instead of doing a straight equals. Running our tests one more time, we can see that they now pass. Now that the search is all working, we can just verify the UI, switching back to the browser, and then typing in a search. We can see that our search actually failed because we have a nil value we didn't expect. So we just need to add a test for that nil value, and that will fix it. We can start by copying our test for a single field and changing it to have a nil cast value, and then we can try running the tests again. Great, now we see the same failure in the test as we saw in the browser, so we can quickly fix this by changing over to the implementation and just adding a safe navigator operator. Running our tests again, we can see they all pass now. Back in the browser, now we can test a few searches and see that everything works just as expected.